So here we have section 6.3, which are trigonometric equations part 2. And the first thing I want to note is these are all different because the equation will not have an argument of plane x or plane theta. Maybe it'll be a 2x, maybe it'll be a 2 theta or a 3 theta or a half x. So we have to figure out ways to handle that when your angle is not just plane x or plane theta. So the first thing I want to point out is that if the angle has two different arguments, like if one is an x and one is a 2x, or one is a half x and one is an x, the first thing you have to do is you have to get the angles the same. And the only way to do that is to use an identity. So at some point you may need your double angle identities or your Pythagorean identities for these. And if you need those, I won't require you to have them memorized. You know, your doubles or whatever at this point, you've already had your memory, stuff on that, so you'll be allowed to use those. So don't panic over all of that. You just have to know when to use them. So you do, however, need to still know your reciprocal, Pythagorean, and your quotient identities. Those you're just expected to know right off the top of your head at any time, okay? All right, so if the angles are different, you have to get them the same by using an identity. And here's the part that's going to take you guys a little time to kind of understand. If you end up with an argument whose coefficient isn't 1, you must rewrite your interval before solving. And we'll talk about what that means. But the final answers have to be back in the original interval. And they will if you work it properly. So there's a whole different mindset that has to go on here. Okay, so let's just kind of like make a list of steps for these. Okay, so the first step we need to make sure is make sure the angles are the same. So we'll get all angles the same. Okay? Then regardless of what your angle is, theta, 2 theta, half x, doesn't matter, isolate the trig function. You can do that by getting it equal to 0. If it's just 1, you just get it by itself. If there's more than 1, you get it equal to 0, and you can factor it, or you can do the quadratic formula, or you can square both sides. Do whatever it takes to isolate the trig function. After you isolate the trig functions, use your unit circle and reference angles to solve for one revolution of your angle. Do you guys understand what I mean by one revolution? Yes?
Like 360?
Yeah. So usually that happens, something like that happens twice in one revolution. So go through the quadrants once, 1, 2, 3, 4, and find any solutions that will work. Here's where things get kind of weird. Depending on the coefficient, you will have to add 360 or 2 pi to all of those answers that many times to generate a second revolution. So you will have to produce the appropriate number of coterminal angles to go with it. For example, if you have a 4x, you would have to add 2 pi 4 times, or actually 3 times, to generate a second revolution. You would add 2 pi 1s to all of your answers. A third revolution, you would add 2 pi again to all of those. A fourth revolution, you would add 2 pi again. So you will produce however many sets of answers you need based on your coefficient. If your coefficient is a half, you actually only have to produce half of one revolution. So you don't have to use quadrants 3 and 4. We're going to look at all that, okay? But you're going to generate multiple revolutions depending on the coefficient by adding 360 or 2 pi to all of your answers. So that depends on the coefficient. So we're going to generate more revolutions depending on the coefficient by adding what to all of our answers? 2 pi if it's in radians, or 360 degrees if it's in degrees, okay? And here's what's really weird. Your last step, divide every answer by the coefficient of the angle. And that will bring all of those answers down and back into the original interval. So that's kind of neat when you see it work. It sounds really complicated, but once you just kind of do a couple, you see that it's really just 2 extra steps at the very end. So I'll pause right here, see if you have any questions, take a few notes, and then we'll just do a couple of examples. For our first example, we would like to solve 2 times sine of 1/2 x equals to 1. We're going to solve it 2 different ways. The first one, we're just going to go over the interval from 0 to 2 pi, but then at the end, we're going to give all solutions so that you're comfortable doing either one. So we have the equation 2 sine of 1/2 x equals 1. How many trig functions are there? Just one. Okay, so since there's just one trig function, I can just isolate it. So we know that sine of 1/2 x is equal to 1/2. Now at this point, if that were a plane x, we would generate off a reference angle, and then we would move around all 4 quadrants to find the 2 places where that happens, right? Because it's a 1/2 x, you're only allowed to go halfway around, okay? So because it's a 1/2 x, you only have to worry about quadrants 1 and 2. Unfortunately for us, sine is positive in both of those quadrants, right? So we still are going to have 2 answers here. So you tell me where sine is positive 1/2. What reference angle?
30.
It's 30 degrees, right? Which would be something pi over 6. Okay, that's our reference angle. And we only want the first 2 quadrants because our coefficient is a 1/2. So we'll go quadrant 1 and quadrant 2. And that happens in both of those places. So in quadrant 1, that would be just pi over 6. And in quadrant 2, that would be what? 5 pi over 6. Okay. So those are not my 2 answers. Okay? Not yet. All right. We've done the first few steps, okay? We've isolated it, we've generated off what we need. We only needed half of a revolution. But let's look at that final step. The final step says after you generate what you need, okay? And we didn't have to go multiple revolutions this time. We actually only needed half of one. So that was perfect. Now it says divide every answer by the coefficient of the angle to solve for x or theta. Let me explain to you what that means. What is my angle? X over 2, right? Okay, so it's not that x equals pi over 6 and 5 pi over 6. It's that my angle equals that. So it's x over 2 equals pi over 6 and 5 pi over 6. And so really, I should divide both sides by 1/2 at this point, because those are angles, but they're not that's not what x equals. That's what my angle equals, which is my 1/2 x. So dividing by 1/2 is the same as multiplying everybody by 2. So if I multiply everybody by 2, I get x equals 2 pi over 6 and 10 pi over 6, right? Which will simplify to pi over 3 and 5 pi over 3. That is what the solution set should be, right there. Questions? Okay, so that's our solution set, and then we really should check it. Do you notice that both of these are between 0 and 2 pi? Okay, well these two right here had to be within half of a revolution. So they had to be between actually half of that, so 0 and pi. But our final answers, after we divide by our coefficient, it pushes them back through to the entire interval. So it's okay for them to be all the way down into quadrant 3 or 4. Does that kind of make sense? Okay, because this one is, what quadrant is that in? It's in quadrant 4, right? Okay, so let's check them. So why don't you guys take a moment and substitute those back into the original. Make sure you're in radians. and see if they work. So we'll pause right there. Okay, so we checked these into the original, and we believe that both of those, when substituted in, makes it equal positive 1, so we're good to go, right? You always check back to the original. So here are two solutions. Next, we want to talk about all solutions. In order to do that, you have to be able to understand what the period was of the function that you solved for. Normally, we would add 2 pi or 360. That's only if the period is 2 pi or 360. This period isn't. If I look at this problem that I solved, 2 sine of 1/2 x. Remember that the period of that is 2 pi divided by the coefficient, which is 1/2. So that is 4 pi, right? That is what you add to each of these to produce new answers. I know that sounds crazy, but that's what has to be done. It's a little bit different than when it's just plain x. So you do 2 pi over b, the period, okay? So for sine and cosine, secant and cosecant, it's 2 pi over b, and that's what you add to each. So we say that all solutions are pi over 3 plus 4 pi n, and 5 pi over 3 plus 4 pi n, where n is any what? Any integer. And that just means we could add or subtract 4 pi to those as many times as we wanted and produce as many solutions as we wanted. And that it would have ultimately infinitely many solutions.